All right, everybody, welcome back. Today we're going to be doing, or I'm going to be showing you kind of problems throughout this second homework worksheet, or this first homework worksheet of parent functions that you will be completing after this and then submitting. So first problem I want to show you again, I already did problems 1 through 3. I did those yesterday in the part 2 video. Make sure you log in there and watch that and make sure you know what's going on. For problem number 4, so here is problem number 4. This one I thought was kind of unique because of this negative in front. We haven't seen one like that yet, so I wanted to remind you as to what happens. Before we do that, let's first figure out what kind of function this is or what family it's from. Since I do see that this is cubed, I know this is a cubic function. So it's a good place to start right there. It's always good to remember like what the base parent function of this looks like. So a cubic function always kind of has this general shape to it. So once I have that general shape in my head, now I want to think about what happened to my locator point. Well, this means we moved up 1, and since this is a -4, that's the guy that lies to you, so always do the opposite, go 4 to the right. Remember, your locator point for this starts kind of right in the middle at the origin, so up 1 and 4 to the right means my locator point will now be located there. Now, we can sit there and say up right or up 1 and then right 4. That should happen at this point in time. But this negative is really going to be the piece that we got to think about a little bit. Now, what the negative does for you, anytime you see a negative out front, what you want to simply say is that your graph is now flipped. And what that means is that instead of your graph looking like this, our graph is actually going to be flipped across the x-axis, and now we'll have a shape that looks more like this. Okay, so anytime it's a negative, it's always just a reflection across the x-axis, or you can just say flipped as well. So just like we did before, once you have your locator points, you want to just make a table. Since we only need to have 3 values, your first one should be where your locator point is, so 4, 1. And then if there's no restrictions on your domain, meaning it's not a square root, you should always pick the number before and the number after for your x values. To figure out what the actual y values are, you're going to need to plug it in at this point. So plugging in a 3, if I plug in a 3 right here, 3 take away 4 will be a -1. -1 to the 3rd power has to happen next. So -1 cubed will end up being a -1. And then that's where the negative in front slides in. So a -1 makes it a +1, plus 1 equals 2 at the end of the day. So when I plugged in a 3, I was really at a +2. Now let's do that one more time, only this time we got to plug in 5. Again, really the biggest piece that you can make a mistake here is going in the wrong order of operations. So make sure you're thinking about PEMDAS and how you evaluate these correctly. So 5 take away 4 is a -1. Oh, I'm sorry, not a -1, +1. So I will then cube that. 1 to the 3rd power is just 1. That's when this negative slides in. So I have -1 plus 1, which of course gives me 0. So when I plug in a 5, I get a 0 out. So 5, 0 is a point for me. Now, since we already kind of know this is a cubic, we know that our function is generally going to kind of look like this. And that's all we need to do. As long as you have 3 accurate points graphed, you're good. Your domain for this will be all real numbers, and your range, of course, will be all real numbers as well, because it will keep spreading out in both directions. So that was problem number 4. I do want to take a look at problem number 5 as well. So again, in this one, we do see that we actually have an absolute value happening here. So we want to write absolute value over here on the line. The +1 is going to move your graph up 1. The +3 here is actually going to move our graph left 3. He's the liar, remember that. And then last but not least, we actually have 2 pieces happening here. So looking at this last one, so okay, hold on. Once you figure out where your new locator point is, you should graph it. Up 1, left 3 means our locator point sits right there. And from there, you want to actually just make sure you know the points you're going to plug in next. So -3, 1 was our locator point. So then we're going to pick 1 to the left and 1 to the right. So a -2, oh, I'm sorry, actually I should go -4 would be the point to the left or before it, and then -2. Now in a minute we will plug those in just to verify and see where those points fall exactly. But a couple of things we want to know. So since we have a negative out front here, what we are going to want to say for our transformations is that our graph will be flipped. So that will be one thing. And then the second thing we want to say is that since we have a 2 out front, this is going to be twice as tall. Right? So really, I got 4 different things that are happening. Up 1, left 3, flipped, and twice as tall that we are thinking about in this graph. Let's figure out exactly what this graph is going to look like. So looking at this one now, plugging in -4. If you plug in a -4 plus 3 would give you a -1. The absolute value of a -1 will be a +1. So now I have -2 times 1 plus 1. Remember, the multiplication has to happen first. -2 times 1 will be a -2, and then -2 plus 1 will give you a -1. So when I plug in a -4, I get a -1. That is, of course, going to be a point over here. Plugging in -2. Now if I come over here and I plug in -2, -2 plus 3 will give us a +1. Absolute value of a +1 is 1. 1 times a -2 is a -2. Should probably be writing some of this down for you. So -2, plugging it in. -2 plus 3 is 1. Absolute value of 1 is 1. 1 times -2 is a -2. -2 plus 1 ends up giving me a -1. So again, we get a -1, so we'll get another point right there, and then we can sketch our final graph of that. So it will look like that. Again, we've identified 3 points that it hits perfectly. Now, it does still have the V shape, but we do see that it is flipped over, and in fact, it is taller as well. So our domain, again, for this will be all real numbers. And for our range, since we do have kind of a high point here, our range will be from -infinity all the way to a +1. Let's look at another one together, problem number 8. So problem number 8, again, I do see that I am cubing something. So this we know will be a cubic. Remember that for any cubic, it's always going to have this general shape, and that your locator point's typically located right at the center or at the origin. Now, we do see that we have this -4, which is going to move our graph down 4. That's not inside, right? There's no parentheses right now. So really what I'm thinking is that like you could put parentheses around if that helps you clarify your thoughts. Now that negative on the outside right here is going to be a flip of your fraction, so we are going to be reflected across the x. So our graph, instead of looking like our parent function, how we sketched it, it's actually, now that it's flipped, will look like this. Right? This part kind of moved up while this part kind of moved down. It was that twist. Now, at that point, since we know our locator point is just down 4 from where it normally would sit, down 4 would mean it's sitting right there. So we're going to make our table. We just need 3 good points. So our first one will be at 0, -4. And then we're going to pick one x before it and one x after it. So plugging in a -1, -1 cubed will end up being a -1. And then the negative on the outside, right, is right there. Now is going to slide in front. 2 negatives make a +1. 1 take away 4 leaves us with 3, or -3. Looking at the other side, if I plug in a +1, we just basically go back through and do all this work again. So plugging in a +1, again, it's important to throw parentheses there, otherwise you can do this in the wrong order. 1 to the third is just going to be 1. Then the negative slides in. 1 take away 4 will give us a -5 total. So when you plug in 1, we get -5, which means our graph, -1, 3 would be right here. 1, -5 would be there. And then since we know it's a cubic, it has to follow those basic, it has to look pretty much like your basic parent function, just shifted. The domain, again, will be all real numbers, and your range will also be all real numbers. Let's do one more of these together, and then the rest of I think you guys will have 5 left for homework. So doing problem number 11. Again, in this one, we do see that we are dealing with the square root. Once we know that we have a square root, then we want to look for any transformations on our parent function. So the minus 4 there is going to move us down 4. Remember, he was on the outside of the square root, so he's the one that tells us the truth. There was nothing happening inside, so we don't have to worry about being lied to at all. And then the last part is this 4 on the outside. So remember, when there's a number out front of it, we just say it's going to be 4 times as tall. So it's going to be a lot taller than the normal one. So our locator point, which normally was at 0, 0, is now just shifted down 4 units. So when we come over there, x and y. Now the square root is really the only one you got to be careful of. When you do this, your locator point has to start at the top of your table. 0, negative 4. Otherwise you start to run into issues. Now you should pick one value over from that. So if we pick a 1 and we plug that in, we're going to get the square root of 1, which is 1, times 4, which will be 4, take away 4, which will be 0. So we will have 1, 0. Now, in the square root function, here is what we know, ladies and gentlemen. Actually, if we go back to our notes from yesterday, the square root function is the only one where we kind of want to jump around. So if this was our locator point, we always kind of want to pick the next x value. And then what we actually want to do is we want to skip to a few more x values that will actually make this work if possible. So if we want to skip, we really want to go 4 up from where our locator point actually would be. And what I mean by that is this. So coming back to your graph here, or to our worksheet, if I go 4 up from 0, 4 would be another good number, right? So this one was just plus 1, and if you make your next one plus 4 from wherever that x value of your locator point would be, you actually can always ensure that you hit nice numbers. So plugging in a 4 right now, if you take the square root of 4, you know that that will be a 2. That is, of course, 4 times 2, which is 8. 8 take away 4 is equal to 4. So I get a 4 when I plug in a 4. So I know that I will have 1, 0, and 4, 4. So this is my square root function right now. Now, the only spot that I think is a little tricky here is, well, okay, I picked the 1. Sure, that makes sense. But this one right there, how do I know to pick 4? There's nothing that says you have to pick 4. You could have officially picked 2 as well. But what's going to give you trouble here is that when you try to take the square root of 2, you're going to get a decimal, and it's going to be ugly. So you will need to use a calculator to help you evaluate that if you go about it that way. So if I were to try to plug in 2, really I could just type in 4 times second square root 2 minus 4. Excuse me. And when I hit enter, it's going to give me a decimal of 1.65. So had I plugged in just 2, that would have worked too, 1.65. I just got to be really accurate when I graph that. 1.65, as you can see, is still right on par with where my function is coming through. So it is fine if we use them that don't give us that nice number, but you should be able to think through and get a number that will work nicely. Now for your domain, once you see the graph, you can see that you go from 0 to positive infinity, and then that you go from negative 4 to positive infinity for your range. Again, ladies and gentlemen, there are 5 problems remaining for you. I believe you need to do 5, 7, 9, 10, and 12. So I'll leave that for you. If you do have questions, please make sure you're reaching out and asking them. Have a great day.